Hi everyone, this is practice formative of chapter 4, permutation and combination, question number 10. So we have to determine the number of arrangement of R out of n objects in each of the following situation. So how many 3-digit numbers that are different that can be formed from digit 1, 2, 3, 4, 5 without repetition. So over here we have 5 digits to choose from, so n equals to 5, and then out of this n, we just need to take 3, all right? So R equals to 3. So part A, we can actually use 5P3 to find the answer. So with this, we can use the formula or we can use the calculator. So in terms of formula, it will be like this. We shall take 5 factorial divided by 5 minus 3 factorial. 5 minus 3 factorial, which is 2 factorial. So we shall write 5, 4, 3, 2 factorial, so that we can simplify with the 2 factorial in the denominator. So we're left with 5 times 4 times 3. So we have 60 as the answer. Okay, this is through the formula. And from the formula, you will notice that the shortcut will be 5P3. We just count down from 5. 5 times 4 times 3. We only multiply 3 numbers from 5 downwards. So therefore, we got 60. Okay, this is by using the formula, but the shortcut. Another way is by the empty slot. Okay, we use the slot method. So since we need to form 3-digit number, therefore for the first empty slot, we will have 5 choices. So 5 choices followed by the second empty slot, we left with 4 choices. So 5 times 4 times 3. And therefore the number of arrangement will be 5 times 4 times 3 equivalent to 60. All right, so that is for A. And then for B, how many 4-letters codes that are different can be formed from the letters in the word rhymes? So R, H, Y, M, E, S all are different. Therefore, we have 6, N equals to 6, and the R is 4-letter codes. So we can use 6P4, all right? Either use the formula or we can use the calculator. Now this round, let's show how we do it in the calculator. Okay, so in the calculator, we put in 6P. So shift, press the multiplication button because on top of it is the permutation symbol. So at 6P4. Okay, so we got the answer 360. 360. Okay, or the shortcut 6P4, we count down from 6 for 4 numbers. So 6, 5, 4, 3. Only up to 4 numbers. Therefore, when we multiply, we will have 360. Next, if we were to use the slot method, so we will have 4-digit number, 4-digit code. And therefore, for the first empty slot, we have 6 choices. So 6, after 1 letter put in, we're left with 5 choices. After 1 goes in, and then left with 4 choices, 3 choices. Therefore, the number of ways that we can form the 4-letter code will be 360. All right, now, the slots method is very useful, especially when we have the arrangement that's set with certain condition. So I would use that more. All right, now next part C, we have to find the number of ways to arrange 7 students in 4 chairs. So 7 students in 4 chairs in this question, our N is actually 7, and then the R is 4. Okay, out of 7 students, we choose 4 to be seated in the chair. Therefore, 7P4. Okay, by using the formula, 7 factorial over 7 minus 4, left with 3 factorial. So we will write 7, 6, 5, 4, and 3 factorial to be simplified with the 3 factorial in the denominator. Isn't it? We're left with count down from 7, 1, 2, 3, 4, 4 digits. Yes. Therefore, this one, after we calculate, we got, let's use the calculator. So 7p4, 840 ways. Okay. And therefore, using a slot method, also the same thing. We have 4 empty chairs, 1, 2, 3, 4. So the first empty chairs, there are 7 students for us to choose from. So 7 choices, followed by 6 choices, followed by 5 choices, followed by 4 choices. So isn't it? It is the same as this one. All right, now let us move on to part D. So in part D, how many ways can 3 car parks? Okay, can 3 cars park in 8 vacant parking lots along the street as shown in the following diagram? So we have 8 parking lots, and therefore our N will be 8. And then our R is 3. Therefore, the number of ways to park will be 8p3. Okay? Therefore, sometimes it is not that the parking lot that we fill in. Sometimes is the 3 cars, okay, 3 cars. Okay, so for this, the first car, it has 8 parking lots for the car to choose. And once this car occupies 1 parking lot, so the second car will left with 7 parking lots to choose from. So sometimes it is not the object that fill in the space. We can allow the space to go to the object. So it works 2 ways, okay? Therefore, 8p3, we use the calculator. So 8p3. Now I use the existing or the function in the calculator. I just change the number N and R. So I don't have to press Shift NPR again. So 336 is the answer. So 336. Okay, we see this, we see the answer, then we get the full marks, okay? Now, next, part E. There are 12 participants in a 100-meter run. Find the number of possible results obtained if there are rewards of medal for champion, first runner-up, and second runner-up only. So we have 3, 1, 2, 3. So 3 positions to fill in. So out of the 12 participants, so the one that go into the first position, which is the champion, so we may have any of the 12. After the 12 goes in, one of them goes in, we're left with 11 participants that may fight for the first runner-up, and then followed by 10 participants to fight for the second runner-up. Therefore, the number of possible results will be taking 12 times 11 and then times 10. Okay, therefore the answer will be 1,320. Okay, all right. Or we use the formula that will be 12 people, okay? They will fight among themselves to get the 3 position. So 12p3. So with this, by using the calculator, so key in 12, shift, call out the function of permutation. R is 3, so we have 1,320. That's it. Okay, so that's all for question number 10.